Okay, so let's move to our next session. This is a very exciting session. We would like to lead you to a lab tour. The lab tour will be offered by our professor, Professor Emir YILMAZ. So now I think that we should switch the camera to Professor YILMAZ. Professor YILMAZ, can you hear our side?
Yes, thank you very much. Can you hear me well as well? I hope everybody's hearing me. Welcome everyone. Welcome to PERCH. This is Precision Engineering Research Group, and I'm Emir Yilmaz, an assistant professor here in our lab. And today I will give you a brief talk about our research and what we do here in Sophia University. So today's agenda will be is shown here. It will be a quick one. I only have 15 minutes, so it's going to be a bit fast-paced one. Hopefully you'll get the overview. So firstly, I would like to introduce myself. There's a point to it. You might ask why is he introducing himself, but we'll get to that. So basically, I was born and raised in Turkey. I was there until high school, and in the fourth year of high school, I went to the United States as a Rotary Youth Exchange student. And after 1 year studying there, I came back to Turkey, did my bachelor's degrees in Sabancı University. And during that time, I actually came to Japan for the first time, to Tokyo Metropolitan University as an exchange student. And I was partially founded by Justo, actually. So thank you very much, Justo. And after my studies in Japan for 6 months, I came back to Turkey, finished my studies, then got into Ford Motor Company and worked there as an engineer for 1 year. And during that time, I realized I want to do a bit more technical stuff, and I looked into some options. And as previous professors mentioned, Sophia University had an English program, which I didn't know, but it came up online. And I applied and got into the program, and I am basically a product of this Green Science and Engineering program in Flash. So I've been here in Sophia University since 2015, and I did my master's degree, PhD, did a postdoc, and since 2021, I work here as an assistant professor at PERCH. So enough about me. So let's go back to the university. And as previously mentioned, Faculty of Science and Technology, we have three different departments. And here in Department of Engineering, we have 3 different areas. In mechanical engineering, we have 7 different research groups. And today I will talk about the precision engineering. So you might ask yourself, what is precision engineering? We can define it in a simple terms. It could be defined as a subdiscipline of mechanical engineering. What we mostly concerned is with designing machines, machine elements, fixtures, and other structures that have exceptionally low tolerance. So when I say low tolerance, let's see, this is a pointer. When you have to, first of all, you have to design it on a paper in a computer-aided design environment. So you set a dimension for its length, its width, or its depth. And in precision engineering, we like to do those paper-written designs. And when you actually manufacture it, those dimensions to be matched almost perfectly together. So we are talking about micro, nanometer level accuracies. So when we do that, if you have low tolerances, you can basically have your products to be repeatable, and you know that if you did the engineering calculations correctly, you know that they're gonna be stable over time, so you can use them for long periods of time. But of course, precision engineering, even though it's a sub-disciplinary of mechanical engineering, shortly we will see in our demonstration phase as well that we deal with electrical and electronics engineering, software, and even sometimes optical engineering as well. So, and this is our research group. We are somewhat small but pretty diverse research group. I work with Associate Professor Hidatake Tanaka, and myself is from Turkey. And since as of last year, we had 1 PhD student. We had 3 master's degree students, 1 from China, 1 from India, and we have 6 bachelor degree students, and he was right here, Tadanak-kun. Hello, if he's watching. He just graduated, so but we still have the diversity. So for our research team in Sophia University as the Precision Engineering Research Group, we are mainly focusing on CFRP. You might have heard about it, carbon fiber reinforced plastics. On paper, these CFRP materials are hard to process, hard to shape, hard to cut. So in our laboratory, we're trying to find new ways to work on these materials, these composite materials. So we use CAD and CAM. CAD stands for computer-aided design, and CAM is computer-aided manufacturing. So basically, initially we design everything on computer, we simulate it on computer, and then see if we are missing anything. And once we clear all the sections, we go to the real life and actually machine the process. So we save time and energy and money, and so on. We also work on EDM, electrical discharge machining process. We will have a demonstration of this in a bit, so I will skip it for now. And we also talk about the work on the surface engineering. You might not really think about it. I also didn't think about it myself since before my master's degree. The surface roughness or the surface feel of your phone, let's say, it needs to be smooth for your daily usage. Sometimes you need a bit more sandier environment for different applications. So we're trying to find what's the optimum values for, let's say, heat transfer, or let's say for friction. And also we deal with tribology, which is the science of wear, friction, and lubrication. And in this case, we're trying to build our own experimental setup, which we use right here in Techno Center. So we are right now in our Techno Center at Sophia University. This is the largest machining center in Chiyoda district. It was built in 1962. And this facility is used by not just me, but the whole faculty members in Sophia University when they want to manufacture their experimental apparatuses. When they want to do something new, a new research, they might need some parts, materials for those. And they come here and they talk to our professional staff, and we basically, well, we get basically help from them. And as students, during your studies at Sophia University, you also have the opportunity to have some practical educations. We have more than 30 machinery over here, from big size to small sizes. So you can have your practical education. You know, you can learn how to use some of the machinery during your studies at Sophia. We also have a Sophia Racing Club. This is pretty interesting. This is a student club, all owned by students, and they sometimes come to us and we discuss ideas, but they also design their own cars and come to the Techno Center and basically build their materials. So these are some available machinery that we have. This Takisawa one is right behind us. If you come to Sophia University, I'll let you know how to use this one. And these are some of the processes that we can do, some like spherical shape, even though when you look at it, oh, it looks nice, it's spherical, but when you think about it, how it's manufactured, it's another concept which we can learn and study here in Sophia University. And my office is only 2 stories up, so it's super convenient for me to come and work on new technologies for manufacturing things and more precisely. All right, so this is my explanation for now. So let's move to the demonstration section and see how we deal with CFRP materials. All right, let's go. So we're gonna move to another smaller area where we have a specific lathe, and Mr. Ryota will talk about the machining processes.
Hello everyone, my name is Yuta. I'm a first-year master's degree student in Precision Engineering Lab. Today, I will demonstrate EDM-assisted turning process. EDM is called electrical discharge machining process, where tiny but powerful sparks are used to erode the surface of the workpiece. In our lab, we are trying to process carbon fiber reinforced plastic. If you ask why, CFRP is lighter and stronger than metal and has excellent corrosion resistance and durability. This is why in recent years, demand for CFRP has been increasing. We see its usage in wind turbine blades, planes, satellite, and even in the health sector. However, during the conventional turning process of CFRP is hard to cut. Conventional methods result in bad surface finish, and additional processes are necessary. If you try to cut it with conventional method, the end product will look like this. Carbon in the CFRP material is conducted. Using this fundamental knowledge, we propose combining EDM process with turning. This is named EDAT, for electric discharge assisted turning. EDAT is a two-step process. First, the EDM process takes place, and then normal turning process. This figure shows how EDM works, and this is a schematic diagram of the lathe. Discharge gap in micrometer level is created between the spool and the workpiece. And then we erode the carbon fiber caused by electric sparks flowing through the insulating air. So let's see how it looks like in real life. Here is the electrical circuit board, and this is the software that we load. And this is a tool, copper electrode, and this is workpiece CFRP. So please come closer and see the actual process. It will be fast, so please pay attention. This is a conventional method. You can see residual fiber, but if you do EDAT, the end product will give clean surface. This is the end. Thank you very much.
All right. Thank you, everyone. I hope you enjoyed our lab tour, and we hope to see you here in Tokyo. And you can also email me or us through these links. So we hope to see you soon here in Tokyo. Thank you. Bye-bye.
Thank you. Bye.